Hello, and welcome to the tutorial on graphical and analytical representation of data, part 2. At the end of this topic, you will be able to explain the advantages of representing data graphically, list and explain major types of graphs used for data analysis. Graphical or visual representation of the tabular or numeric data is one of the most popular and commonly used analytical techniques. Here, the visual representation is done using graphs or charts, such as bars in a bar chart, lines in a line chart, or slices in a pie chart. For such visual representation, we neither use any algorithms, nor any complex models, nor any complex mathematical formula is involved. It is one of the simplest techniques for drawing insights from the data. This not only helps us to study the relationship between variables, but also helps to identify the trend and patterns across the variables. Now, let us talk about some of the major types of graphs which are commonly used for data analysis. The graph shown here is a line graph. It represents graphically the runs scored per over in a cricket match. Here, the x-axis or the horizontal axis represents the over numbers and the y-axis or the vertical axis represents the runs scored in an over. So based on the runs scored per over, the data points are plotted based on x and y values. Once the points are obtained, the dots are joined using a line. Looking at the chart, we can easily identify which was the most expensive over and which was the most economical over. Such inferences or conclusions can be drawn from this graph. Now, instead of plotting the dots, we could have represented the chart using bars. Then the chart would have been called a bar chart. Here is an example of a bar chart. Now, let's move on to a special type of bar chart called histogram or frequency polygon. A histogram is used to count the frequency of occurrence of an event. The only difference from a bar chart is that there are no gaps in between the bars. It is used to represent continuous variables only. In our example of cricket match, let's represent runs scored in an over on the x-axis and the number of overs in which those many runs were scored on the y-axis. The runs represented on the x-axis are categorized into intervals of 2, as x-axis values in a histogram are represented in intervals which are known as bins. So here, the intervals would be 0 to 2, 2 to 4, 4 to 6, etc. The frequency of those many runs being scored in the overs is shown on the y-axis. In the chart here, you can see that y-axis value for 0 to 2 runs interval is 4. That means there were 4 overs in which runs scored were between 0 to 2. Similarly, you can see that y-axis value for interval 6 to 8 is 16. That means there were 16 overs in which runs scored were between 6 to 8 and so on. In this graph, we can see that most of the overs had 6 to 8 runs scored in them. There are a few low scoring overs and a few high scoring overs. So, there is a pattern of inclining, reaching a maximum frequency and then declining. If we draw a smooth line based on the frequencies, we will get a bell-shaped figure as shown here. Whenever our histogram is bell-shaped, that is, slowly the frequencies increase at some point and after that it starts decreasing, we say that the data is normally distributed. We see normally distributed data at several places in nature. For example, if you were to plot a histogram with number of people in each height range, you might see that a few would be rather short and a few would be quite tall, but majority would fall in a specific range. Same is true for marks in an exam. Some would score high and some would score low, but majority would hover around a specific range. For modeling, we must always have normally distributed data. In case our data is not normally distributed, we use mathematical treatment to make the data model ready so that it follows a normal distribution. Now let's move on to pie charts. As the name suggests, pie chart is displayed as pie or a slice or a piece of a pizza. Each portion of the slice represents the share of the variable. It is one of the widely used graphical representation chart where we want to display the proportion of different values or attributes. Let's consider the cricket match example. We want to find out which players made most of the runs. Player 1 made the most contribution of 55%, followed by player 2, 3 and 4. The rest of the players contributed to 10% of the total scores. Now, we will discuss scatter plots, one of the most useful graphs in data analytics. This is a two-dimensional visualization where each point is represented by a dot and each point is obtained by the intersection of values of two variables represented in x-axis and y-axis respectively. This graph is very useful in informing us the relationship between two variables. Sometimes we have a line drawn between the dots, and this line is the best fit line based on the dots or the points. For example, let us consider the match which we have talked about earlier. Now, we have the information of both the innings and we are focusing on the dot balls per over. This is displayed using a scatter plot. From the graph, we can infer that the initial overs fetched maximum dot balls, and as the innings progressed, the dot balls were reduced. In mid-innings, we see both the teams got some momentum and had minimal dot balls or scoring balls. If we draw a best fit line based on the points, the line will first decrease and then it will start increasing post 10 overs. Now let's look at box plots. Box plots, also known as box and whisker plot, is a graphical representation of the statistical summary of numeric variables. This graph is represented in a rectangular format, with adjoining whiskers at both ends and a line bisecting the rectangular block. From the graph, we can obtain the following: minimum value, first quartile or the 25th quartile, median value or the 50th quartile, third quartile or the 75th value, interquartile range, maximum value, outliers. Now, what are quartiles? The quartiles divide the data into three equal parts, namely 25th quartile or the first quartile, 50th quartile or the median, 75th quartile or the third quartile. The difference between first and third quartile is known as the interquartile range, which is equal to the length of rectangular block in the graph. Suppose our data consists of 100 observations and we arrange our data in ascending order, then the first quartile will be represented by the 25th value of the dataset. The second quartile will be the 50th value in the dataset, and it will also be the median value, and the third quartile will be the 75th of the dataset. Let us discuss the box plot with an example where we consider Sachin Tendulkar's first 100 one-day international match scores. From the above graph, we can figure out the maximum value is 115. It was the highest score for Tendulkar in his first 100 one-day international matches, and 0 was his minimum or the lowest score, and is represented by the whiskers. Now, if we arrange all the 100 scores in ascending order, then the first quartile or the 25th record will be 8, which means that in 25 innings out of his first 100, Tendulkar scored 8 or less runs. The 75th or the third quartile will be at 52 runs, which means that in 75 innings, he scored 52 or less runs. Another way to read this could be that in 25 innings, he scored more than 52 runs. The length of the rectangular block will be of 44 runs, which is the difference between third and first quartile. From this rectangle or the interquartile range, we figure out that maximum times runs scored by Tendulkar in his first 100 innings were between 8 and 52. The median score for Sachin Tendulkar or the 50th score is 24 runs. Now, suppose for the 101st match, the data obtained for Tendulkar is 500. Now, 500 will be considered an outlier. Outlier is represented on the vertical axis of the box plot. As outlier represents the extreme magnitude of the data points, it is above the top whisker as shown here. Now, we will discuss time series. This again is a representation of the line graph where x-axis contains time and the y-axis can be any numerical variable which changes with time. In this example, we are considering the housing prices. Now, so far we have learnt about various types of graph. Let us now look at some important points we need to take into consideration while using graphs. The type of graph used impacts our understanding of the data. We always must be careful how we are representing the data and the type of graph used. So that's it in this tutorial. See you in the next one.